So today we're going to be looking at sequences and series. Starting with types of progressions, we have arithmetic progressions, geometric progressions, harmonic progressions, arithmetic geometric progressions, and miscellaneous progressions. So let's start with arithmetic progressions. So in arithmetic progressions, the nth term is given as a plus n minus 1 times d, where d is the common difference between two consecutive terms. So you can just subtract two consecutive terms and get the value of d. An is the nth term and a is the first term. And the sum up to n terms can be given as n by 2 times a plus l, where a is the first term and l is the last term, which is also written as n by 2 times 2a plus n minus 1 to d. And this can be derived by simply substituting the value of the last term over here. And let's say we have three consecutive terms in an AP, A, B, and C. The relation between them can be given as 2b equals a plus c. And let's say they asked you the ratio of the sum of two APs as xn plus a is to yn plus b. Then you can get the value of n as 2r minus 1, where r is the ratio of the terms that they will be asking for in the question. Let's take a look at arithmetic means. Let's say we have these terms in an AP with a common difference d. So we can get the common difference with the following formula: d equals b minus a times n plus 1. And b is obviously a n plus d, the common difference. And the sum of the arithmetic means of this set of terms can be written as n by 2 times a plus b from the same formula over here, which can also be written as n by 2 times a1 plus an. So one thing you need to remember is that the sum of the first and last terms is also equal to the sum of the second first and second last terms, which is also equal to the sum of the third and third last terms, and so on. So that's something you can remember about arithmetic progressions. Moving on to geometric progressions. So in geometric progressions, the nth term is given as a times r to the n minus 1, where a is the first term of the geometric progression and r is the common ratio. And how you can get this common ratio is by dividing two consecutive terms. So let's say you have a and b. So this is the first term and this is the second term, the two consecutive terms. You can get the common ratio by just doing b divided by a. And for sum up to the nth term, we have two cases in geometric progressions. So let's say that the value of the common ratio, the absolute of the common ratio, is less than 1, and use this formula, which is a times 1 minus r to the n over 1 minus r, because r is less than 1, so you get a positive value. And let's say, well, you don't have to get a positive value, but okay, the absolute of r is greater than 1, then you use this formula, which is the sum equals a times r to the n minus 1 over r minus 1. And once again, a is the first term, r is the common ratio, and n is the term to which you need the sum. And even in these cases, we can have a special case. So let's say over here we have r tending to infinity, then the sum also tends to infinity. And over here, if r tends to infinity, so if r tends to infinity, this thing becomes 0, and so you just have sum equals a over 1 minus r. This is only when r is less than 1, and also the n is tending to infinity. My apologies. Over here as well, n tends to infinity. So when n tends to infinity and you're multiplying a number that's less than 1 over and over and over again, this thing becomes 0, so you have the sum to be a over 1 minus r. Also, let's say you have three consecutive terms, a, b, and c. So the condition for these terms to be in a geometric progression is that b squared equals ac. Just something you might want to keep in mind. Just like for an arithmetic progression, you have 2b equals a plus c. For geometric progressions, it's b squared equals ac. Let's take a look at geometric means. So let's say that a, g1, g2, g3, gn up to b are in a geometric progression with the common ratio r. So obviously we have a total of n plus 2 terms. So these are n terms, g1 to gn. Then you have a and b, so that's 2 more, that's n plus 2. So obviously with using the formula that an equals a into r to the n minus 1, which is the formula for the nth term, and over here n becomes n plus 2. When you get to b, you get b to be a times r to the n plus 1. So that's basically n plus 2 minus 1, which becomes n plus 1. So from this we get r to be b over a power 1 by n plus 1. And that's how you get the common ratio when you have n terms in a geometric progression. And let's say you only want one geometric mean between a and b, and you can do square root of ab, and then let's say a and b are both positive, then you take the positive sign for square root of ab, and if a and b are both negative, then you take minus square root of ab, obviously, because the geometric mean would be negative as well. Let's say you want a product of all the geometric means between a and b. Then what you do is you multiply a and b and take them to the power of n divided by 2. That's ab to the n by 2. So the next topic is harmonic progressions. Harmonic progressions are quite easy again. So basically, let's say you have a, h1, h2 all the way up to hn and b in a harmonic progression. Let's take the inverse of the terms. So that's 1 by a, 1 by h1, 1 by h2 all the way up to 1 by b. So these inverted terms are actually in an AP. So now you can apply all the AP formulas to the harmonic progression. And the common difference of these terms, the inverted terms, will be a minus b over ab times n plus 1. Or you can just subtract two consecutive terms as well, just like we did in APs. That's it. So the next topic is arithmetic geometric progressions. The nth term in an arithmetic geometric progression is given as a plus n minus 1 times d into r to the n minus 1. So this is the arithmetic progression inside the braces, and you have a common ratio outside that term. So it's like an arithmetic progression and also a geometric one. So obviously it's an arithmetic geometric progression. One thing that they ask very often is to find the sum up to the nth term of some given AGP. So what you do is you multiply the sum by the common ratio and then shift it by one term. Shift the summation by one term, and then you subtract it. Subtract the two equations. You have the sum and then you have the sum multiplied by r. You subtract them and then you get the sum up to the nth term. You have a direct formula for that, which is super lengthy, and I personally don't memorize it because I think it's a waste of memory space. But if you think you can memorize it, good for you, go ahead. So what I like to do is I simply follow these two steps. Let's say this is the given AGP. I only took 4 terms because we want it to be simple. So obviously, let's say they wanted us to find the sum of this AGP. So I have calculated the sum to be 49 manually. Now let's try to do this. So basically the sum would be 1 plus 2 times 2 squared, 2 times 2 plus 3 times 2 squared plus 4 times 2 cubed. Basically I just wrote these terms in the form of a general term of the AGP, which is like the arithmetic term multiplied by the common ratio to the nth power. So the first term is 1, and then I have the next term of the arithmetic progression as 2 multiplied by the common ratio 2, and then I have the next arithmetic term 3 multiplied by the common ratio squared. You get the point. So now the next step was to multiply the sum by the common ratio. So the common ratio here is clearly 2. I'm just going to do that. 2 times the summation equals, and we also need to shift the term by 1, right? So that becomes 1 times 2. So I basically just shifted it. So multiplying this by 2 like we did on the left side, and then I shifted it by one term, plus 2 times 2 squared plus 3 times 2 cubed plus 4 times 2 to the 4. Okay, now we're just gonna subtract them like mentioned above. So you have to subtract this from the first equation. Let's do that. Basically that's a minus and a minus, 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 minus. That becomes minus Sn equals 1. That's 2 minus 1, so that's once again just 1 into 2, so that's 2. That's 3 minus 2 into 2 squared, so that's 2 squared. And then 4 minus 3 times 2 cubed, which is simply 2 cubed. And you just have minus times 4 into 2 to the 4. So what would usually happen is that you would get a geometric progression over here. So, well, since this particular progression is very small for the sake of it being an example, but usually in the question you would get a much bigger progression, so you can just simply apply the formula for the summation of the n terms of a geometric progression and get the sum. And then, well, you just have this last term left over, so you just do the addition or subtraction, whatever sign you have over here, and that's it, you get your sum. So for this particular question, after you find the sum of these few terms and you subtract this, you also have to multiply both sides by a minus in order to get the summation. So actually let me just finish that up. This is like 16 4 64, that's minus 64 plus whatever help you have over here, which is 8 and 4 12, 12 to 14 15, so that's minus 64 plus 15, which I believe is minus 49. We have a minus over here, so the sum actually becomes 49, which is the sum we have earlier. There you go. This over here is the sum for an infinite AGP. So basically it's this very same formula except n tends to infinity. So this one becomes 0, assuming that r is less than 1, and then this term also becomes 0, so you just have like a by r minus r plus dr over 1 minus r squared. Now, do you need to memorize this formula? Well, that's up to you, but obviously you don't have to. You can simply solve it with this very same method. Now these are just a few important formulas as to the sum of the first and natural numbers, which you already know is n into n plus 1 over 2. The sum of the first n squares is n times n plus 1 to n plus 1 over 6. And then you have the sum of the first n cubes, which is this one, which is basically like just the natural number 1 squared. So yeah, it's recommended to memorize all of these. Well, it's required to memorize all of these. So this is another commonly asked model, and people get scared just looking at it, but it's actually not that scary. We're gonna solve it together. Basically what happens is summation of r equals 1 to n, multiply and divide it by 2. So where do you get the 2 from? Basically you have 2 over here and then you have a 0, that's like a 2. You subtract r plus 2 minus r, so that's a 2 over r into r plus 1 times r plus 2. So that's summation r equals 1 to n. You would basically just write this 2. Actually you have to multiply and divide it, sorry. So that's half times summation r equals 1 to n, r plus 2 minus r over r into r plus 1 into r plus 2. What happens now is half times summation r equals 1 to n. Now you divide the terms. 1 over r into r plus 1 minus 1 over r plus 1 times r plus 2. So I hope you can notice that when you actually substitute the values, you get the terms cancelled and you only have the first and the last terms left. So what that becomes is half times 1 over, so you only get the first term over here because the rest of them get cancelled, 1 plus 2, 1 times 1 plus 2, minus 1 over n plus 1 and n plus 2. So that's like the last term. So that's just half times 1 by 3 minus 1 over n plus 1 and n plus 2. That's that question for you. And this can be done in a similar way. So what you do over here is you multiply and divide it by 3. So that's that equals 1 to n, 1 by 3 times 3 over the denominator, and then you write 1 by 3 summation, and you write this 3 as r plus 3 minus r, and then you do the same thing, you divide the terms over here as well. That's how you approach these questions. And so on simplifying for this one, you're going to get 1 by 3 times 1 by 6 minus 1 over n plus 1, n plus 2, n plus 3.